Okay, so this is lesson 1, which is going to cover algebraic expressions, solving linear equations and inequalities, and variation. Okay, so these are some topics that, of course, will pop up on the ALEX test. And so it's a good idea that we have some exposure to them now. So let's see. All right. I'll just go ahead and jump to the example since we're trying to hurry and do this in half the time. Okay, and so some of these questions may seem familiar. Some of them may not seem so familiar. That's fine. We'll start with some that seem pretty simple, possibly. Evaluate the expression. So I do want to mention the difference between the word evaluate and solve, right? Those are two very different ideas. So evaluating is whenever you are trying to simplify something or you're trying to find something out about an expression, okay? Where if you are trying to solve an equation, you're again trying to solve an equation, you're looking for a solution. Okay, so here we're asked to evaluate. In other words, we're given information about this expression 3x plus 5. We're given the information that x is 2. Okay, and so I want to figure out what is this going to be with that new information. All right, so that's how you should think about evaluate. So 3x plus 5, 3 times 2 plus 5, and then you just work that out, right? 3 times 2 is 6, 11. So to evaluate, we found out the simplified state of the expression with that additional information. This one I did want to talk about really quick. I do want to show you that, and this is just a trick to remember whenever you are taking any math class, and you probably already know this, but just in case you don't, let's talk about it. So if you're given an expression like this, all right, and you're using your calculator to figure it out, don't type in 10 plus 4 divided by 2, right? Because that's not correct, right? 10 plus 4 is a grouping symbol, right? Or the fraction bar is a grouping symbol. So 10 plus 4 is 14. Divide that by 2, okay? And so if you typed in like this, the calculator would read that as 10 plus 4 divided by 2. Well, order of operations would say that I do 4 divided by 2 first, which is 2, which would give me 12, right? And that's not the right way to do it, right? Do 10 plus 4 first. So you can put parentheses around it in your calculator, then push divided by 2. Now the calculator knows, do the 10 plus 4 first to get 14, and that would give me 7. Okay. So I did want to mention that really quick. Type it in the calculator. Remember, fractions are a grouping symbol on their own. Okay, let's talk about multiplication, right? So multiplying expressions together, people tend to talk about FOIL. I don't like to say FOIL because it's not applicable all the time. Okay, instead, I like to say distribute because that will always hold true. Now, FOIL would work in this problem, but I don't want you to think about it in terms of foiling, right? I want you to think distribute the x. Okay, so if I distribute the x, x times x is x squared. X times 2 is 2x. 3 times x is 3x. 3 times 2 is 6. Okay, so I distribute each term, right? Distribute the x, I distribute the 3. Then you should combine like terms if possible. So I have 2 x's right here, 2x and 3x. If I add those together, I get 5x. Okay, so these two expressions are equivalent. If I were to graph both of them, I would actually get the same exact graph. Okay, let's solve the equation. Okay, this is the next part of solving equations. And so I want to show you a quick trick. If you don't know it already, which you may know, but maybe not, you want to try to eliminate the fractions in your first go around. So you're not dealing with the fractions the entire time. And so what I'm going to do first is look at my 3 denominators and find the least common multiple, okay? Least common multiple, which, you see that abbreviated as LCM, the least common multiple. So 2, 3, and 5, I want to know what is the smallest number that all 3 of these go into. Okay, and you don't have to make a table with it, but sometimes it's easy to see. If I count by twos, 2, 4, 6, 8, 10, 12. So the smallest number, of course, will take the longest to fill out. I'm going all the way to 30. Okay. And count by threes, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. And I'll just stop there. And then 5. Okay, so this is what we're talking about, right? Least common multiple. If you look at all the multiples, right? If you count by twos, count by threes, count by fives. Which one do they have in common? The smallest number that they all have in common? 30, right? There's nothing smaller than that. It's all 30. So 30 is my least common multiple. 30 is what I'm going to use to simplify this equation. So I'm going to go and write -5/2 plus 1/3 x equals -6/5. I'm going to multiply both sides by 30, the least common multiple. All right, so that transforms the problem. So I'm going to ignore all of this stuff here, and I'm just going to work with this right here. If I distribute this 30 times -5/2, you can simplify that. Think about that instead of 30 times -5/2. Think about if that 2 were actually just under the 30. You can divide that first, actually. So 30 divided by 2 is 15. So really the problem is just 15 times -5, which would be -75. 30 times 1/3 x, do that right here. Okay, again, you can divide it. 30 divided by 3 is 10. So that's really just 10 times 1x, which would be 10x. And then -6/5 times 30. Again, divide it. 30 divided by 5 is 6. -6 times 6 is -36. Okay, so we transform the problem into whole numbers and that are integers, and that's usually better to deal with for people who don't like fractions, right? If you get nervous when you see fractions. And so I'll solve this by adding 75 to both sides, right? Those get canceled out. And that would be, what is that, 39? I don't trust my brain anymore. Divide both sides by 10. And typically you want to leave that as 39/10. You wouldn't want to write it as 3.9. Usually if you're typing it into Alex, typically you just want to leave it as a fraction. If you can reduce it, of course, reduce the fraction. All right, so solve a compound inequality. So the difference between, of course, an equation and an inequality is that an equation, you're looking for one solution typically, or maybe two. Like you're looking for a specific number of values. Okay, so like in the last example, we were looking for one solution, which was 39/10. Here, we're looking for a range of solutions. All right, and so let's kind of work this out. n-3 is less than -7. 5n-2 is less than 13. And I want to solve these individually. So on the left side, if I were solving that like an equation, I would add 3 to both sides. And on the right, if I were solving that like a regular equation, I would add 2 to both sides first. That would cancel out the -2. 13 plus 2 is 15. Divide both sides by 5. And so we have these two ranges of values, right? So numbers that are less than -4, numbers that are less than 3. Those are both solutions to the individual components. Now, since it did say they want the solution where you have all the values of n that are both less than -4 and less than 3, it helps to maybe visualize that on a graph. So I'll draw a number line, which ranges from -infinity to +infinity. And so what is that going to look like? We got 0, 1, 2, here's 3, 1, 2, 3, 4, here's -4. And we're going to have on the left, n is less than -4. So here's -4. And everything less than -4 is this way, right? That's where you're going to find -5, -6, and so on. That's all the less than -4s. Okay, less than 3. Well, here is 3. Everything less than 3 is over this way. So it's going to cover all that ground. All right, I do want to quickly comment. Notice how I have these circles here. They're not, they're not filled in points. They are open circles. That's because we're not interested whenever n is -4. We only care about when n is less than -4. If I said n is less than or equal to -4, well, then, of course, I would do that. Okay? Okay, so yeah, we're not interested when n is less than or equal to -4, so I will take that off. All right, but it does say and, so we want the solution set when n is both less than -4 and less than 3. And just by the graph, that means where do these two things overlap each other, right? And so they overlap each other from as far left as -infinity, and this is interval notation, as far left as -infinity, all the way up until -4. And I'm putting these parentheses right here. This is called interval notation, which is what the question asked for right here, right? Interval notation. And that just means it's a shorthand way of graphing it out. It lets you know that the region of overlap starts as far left as -infinity and continues as far right as -4. All right. I do want to comment real quick. If this were, let's say, a closed circle, again, if this were less than or equal to -4, you would use a bracket instead of a parenthesis. Okay. Don't know if that's going to come up later or not, but there you go. Okay. The last thing we need to talk about is variation. And we'll do one example about that. Basically, what you want to watch for, the first two are the most important, I think. These terms, they basically tell you what to do in the problem. Okay. Varies directly, varies inversely. If it says something varies directly with x, y varies directly with x, then that means this is the formula that you're going to be working with, or some form of this formula. If it says inversely, think about inverses or fractions. Okay, so you'll see y equals k over x. So k is just the constant of variation. That can be any letter basically, but it represents a number that's going to be a constant. So typically you're looking for an equation like y equals 3x, okay? Or y equals 3 over x. Most of the problem is actually just trying to find that value, right? K value, okay? And then writing out the problem. So varies jointly is typically what they'll use whenever they are combining multiple variables. So it might say varies jointly with x and the square of y. So that's how that would look. Y equals some number, x, y squared. Okay, so it really just depends. Varies jointly, you just have to watch the wording of it. All right, so write an equation that expresses the following relationship. Okay, and I know this is one that you could see on the ALEKS test. So m varies directly with the square of t and inversely with the cube root of p. Okay, so there's that varies directly part. So m varies directly with the square of t. So I'm just picking this apart. M is first listed, so that's actually going to be like my y equals in this case. And that's what is varying. Varies directly with the square of t. The square of t. So that would be, of course, t squared. And inversely, so there's a fraction component, inversely, with the cube root of p. Okay, so that means at the bottom here, I want the cube root of p. Okay, just break it into pieces, right? Varies directly, applies to the square of t. So k times t squared. Inversely, there's the cube root of p. So that's on the bottom. Okay, and they don't even ask you to find the k value. So that would be my formula. Okay, and I think that's it. So now I will once again stop the recording this time. So officially this lesson is over.